guide for the chapter 7 test. So you should see for 7.1, all you're going to need to do is verify one of the three identities. I'm going to do all three though, just so you can see what's going on. Remember, the first rule is always pick the more complicated side. I see one little fraction here on the left. I see a lot of different terms over here on the right. So I'm going to pick the right. Once I do that, the second way to do this quickly is to turn everything into sine and cosine. So tangent turns into sine over cosine. Since it's squared, these are both going to be squared. I have 1, and then I have a product over here. So tangent is going to be sine over cosine. Secant is 1 over cosine. So I looked at what I have here. I'm going to have to multiply these two things together. So that's going to be sine over cosine squared. And it occurs to me then that I have two cosine squared fractions. So let's get our 1 to have the same common denominator. So multiply by cosine squared over cosine squared, and that's 1. Since I have a common denominator, I can add all these together. So the denominator stays the same when you add fractions, and I'll have sine squared t plus cosine squared t plus sine t. Well, sine squared plus cosine squared, that's a Pythagorean identity. That's just going to be 1. So now I have 1 plus sine t in the numerator over cosine squared in the denominator. And that's what I had. That's what I was supposed to get. So I am done. So you circle it, you smiley it, you something it, so that I know that you are done. The second one that you have the option to verify. So the first thing I did was, okay, usually addition and subtraction is easiest. So I started there, and I went cosecant is 1 over sine, secant is 1 over cosine. And I looked at that and I was like, well, yeah, I can get a common denominator by multiplying them by each other, but that's not going to get me any closer to my goal of sine. So I crossed it out. I abandoned it. And I figured, okay, let's try the other side. So I have a victory V, which you can only make V-shaped. You can't do it upside down. So I break apart and get 1 over sine, and I get tangent over sine. So once I do that, I have 1 over sine. Well, that's cosecant. That's a good start. And then I have tangent, which is sine over cosine, divided by sine. When you are dividing fractions, you are multiplying by the reciprocal. So multiply by the reciprocal, because this is really sine over 1, right? So when I multiply, I'm going to get sine over sine times cosine. So the sines will cancel, and this will just be 1 over cosine. Well, 1 over cosine is secant, and that's what we were supposed to do. The last verify problem. There we go. More complicated side, that would be the left on this one, because the right just has cosine. So I'm going to get a common denominator because I have two terms here. There's this little 1 hanging out here. So the denominator is going to have to be 1 plus cosine theta. So I multiply the denominator by 1 plus cosine theta. What I do to the numerator, I have to do to the denominator, and vice versa. So I have 1 plus cosine x over 1 plus cosine x. It doesn't matter that I change the variable. It's a variable. It can be whatever we want. But anything over itself is 1, so it makes sense that we've gotten that. So let's add everything together. So when we add or subtract fractions, the denominator stays the same, so it's still 1 plus cosine x. And now I have 1 plus cosine x minus sine squared x. Well, that's not something that I can combine. So I'm going to use the Pythagorean identity to make sine squared into 1 minus cosine squared. But I have to remember there's a minus sign on the outside. So I'm going to end up having to distribute that minus sign. So I'm going to have minus 1 plus cosine squared. And that's what I have here. I kept the 1 plus cosine x from the beginning. And then I have minus 1 and then plus cosine squared. Well, 1 minus 1, those are going to cancel. And so now in the numerator, I just have cosine x plus cosine squared x. And you can't cancel anything unless it's either multiplied or you could take it out of everything. And that 1 messes that second part up. So let's take the greatest common factor out of the two things we have left, because then we'll have multiplication. So if we take a cosine out of both of those, which I did, when I take a cosine out of cosine, I have 1 left. And then cosine squared, if I take out a cosine, I have a cosine left. And if you don't believe me, try distributing it back in, and you should have cosine x plus cosine squared x. Well, now I have the whole bottom, and I have 1 plus cosine x, and they're the same, so I can cancel them out. So I end up with cosine x. Remember, start with the more complicated side, turn everything into sine and cosine. Pythagorean identities are good when you're squared, and common denominators. So then we go to 7.2 and 7.3. 7.2 and 7.3 tells you you're going to have to use sum and difference formulas. For number 2, they set it up for us. We plug 45 in for A, we plug 30 in for B, we have our formula. Remember that cosine of 45 is radical 2 over 2, so the cosine disappears. Goes for cosine of 30, sine of 45, sine of 30. Order of operations say we need to multiply before we do any subtracting, so we multiply. A radical times a radical can work, but at this point you cannot subtract radicals unless they have the same inside number. So our final answer is just going to be radical 6 minus radical 2 over 4. Number 3 is a little bit harder. Number 3 says to use the sum or difference formula right up there. I drew an arrow, but it's not written as a sum or a difference. So we have to find one. And we're going to find unit circle things. So what I did on the side here is I wrote all of my unit circle things. I have pi over 2, pi over 3, pi over 4, and down there that's supposed to be pi over 6. And I wrote them in 12s because that's what I have over here. So pi over 2 is 6 pi over 12, pi over 3 is 4 pi over 12, pi over 4 is 3 pi over 12, and pi over 6 is 2 pi over 12. Well, which of these add or subtract to be 5 pi over 12? Well, 3 pi over 12 plus 2 pi over 12 is 5 pi over 12. So I can have pi over 4 plus pi over 3 equals 5 pi over 12. And then I'm going to have to plug it into the difference formula. The sum formula, excuse me. Looks like my answer got cut off here. Oh, no, I didn't. I went this way. So when you plug it in, we get tangent of pi over 4, which is 1, tangent of pi over 6, which is 3 radical 3, etc. Since we have a fraction and a fraction, I'm going to multiply everything by 3 so that all of the denominators cancel. So I'm going to multiply everything by 3. It's 3 times, 3 times, 3 times. And I get this mess, which I need to rationalize. So I'm going to have to multiply by the conjugate, which means we're just going to change the sign here. What I do to the bottom, I have to do to the top. On the bottom, you'll have the difference of 2 squares, because that's how we set this up. By multiplying by the conjugate, you will get the difference of 2 squares. So 3 times 3 is 9, minus radical 3 times radical 3 is radical 9, which is 3. Up on the top, you're going to have to FOIL. So 3 times 3 is 9. We'll have radical 3 times 3 and 3 times radical 3, which will be 3 radical 3 plus 3 radical 3, which will be radical 6. Radical 3 times radical 3 is 3. So we'll get 12 plus 6 radical 3 over 6. And we could take 6 out of all of the outside numbers. So we will end up with 2 plus radical 3. I am going to get cut off here, so I'm going to start a new video for the second page.